Hello students, this is Mr. Parrish again. We'll be going through the part 2 of the atomic theory slides. So again, you can follow along in your notes on pages 3 or 4. You'll see a chart that depicts the 5 major scientists. I'm just going to finish up with the last 3 and talk about the key things that you should know about them before moving on in their experiments. So we ended yesterday with John Thomson. His model was called the plum pudding model. It looks like from what I saw today, most of you could find that out about him. Just a couple misunderstandings I want to clear up about him before the quiz tomorrow. A lot of you right now have been saying that, or been depicting that he has a nucleus in here. The thing you need to know about Thomson is that he recognized that there were atoms, and he found out that there were these negatively charged things called electrons. So he was the one who discovered the electron. He had no idea there was a nucleus or a neutron. Okay, so he was only sure that there were these negative things within the atoms called electrons. Okay, and that's pretty much all he knew, and this was called a plum pudding model. And it kind of looked like this, where this was the big atom, and then the electrons were kind of dropped in there like plums. The next scientist we're going to talk about is Ernest Rutherford. He's really famous for the gold foil experiment. Okay, so how this experiment worked is, so this is what he expected to happen. So he was looking to confirm Thomson's idea that the atom was mostly empty space with electrons in there. Okay, so he was expecting to shoot alpha particles, which are these things here. So this is called an alpha particle emitter. So an alpha particle is something that you shoot it onto this special detecting screen, and it shows up as it detects. So these are individual particles that you can shoot at things, and they will actually tell you whether something's in the way or whether it's not. So what he was expecting was that most of the alpha particles would pass right through the atom. This is a picture of the atom here. They would pass right through the atom, and then he wouldn't see any deflections. Okay? But what actually happened is most of the atom, or most of the alpha particles, about 99% of them, right, passed right through the atom, no problem. And this is what he saw on his detection screen. So he had a gold foil here that he was shooting these alpha particles through. So the alpha particles went through the gold foil, right? Mostly, 99% of them ended up in this area concentrated here. But what he discovered was that some of them were actually bouncing off. That 1% that he was missing, right, were scattering all along this detection screen, so all around. So 99% ended up to go straight through the gold foil, and then that 1%, only a couple alpha particles were actually hitting other parts of the detecting screen. Okay, so he was really confused by this, and he really didn't understand what he was seeing, but he concluded that they're hitting something, right? And what that something was the nucleus. So it was passing through the atom, which is mostly empty space, passed through the electrons, but every once in a while it would ding, hit that neutron, or hit that nucleus, right? That densely big nucleus full of those protons and neutrons, right? And it would bounce off and hit the detector screen. Okay, so that was Rutherford's main conclusion, or main discovery, was that he discovered the nucleus. He knew it was positively charged, okay, and he knew that it was larger than electrons. But most of the atom is still empty space. Most of it is the neutron, or that's why only 1% actually hit the nucleus, because most of the alpha particles went through mostly empty space. All right, so conclusion number 1 from the gold foil experiment. I kind of talked through these. Okay, most of the alpha particles passed through the gold foil and were not deflected. So that means that the atom is mostly empty space. So as I was concluding there at the end, the atom is mostly empty space because the alpha particles pass through. Conclusion number 2. About 1 in every 10,000 alpha particles, so actually I was wrong, even less than 1% of the alpha particles were actually deflected. So the conclusion was that Thomson's plum pudding model was actually incorrect, and atoms contain a small, positively charged center in the center, which we call the nucleus. So the plum pudding model would be missing this nucleus, but after Rutherford discovered the nucleus, this is what the diagram actually sort of ended up looking like. Moving on to Bohr. Bohr proposed that the electrons could only exist in certain energy states. So there's lots of information about Niels Bohr. You're on YouTube right now. You should just YouTube him and look up some stuff on Niels Bohr. You can see lots of diagrams, lots of working models on his model. Okay, his model was kind of based on the solar system. So he recognized that there was a nucleus and there were electrons, but he wanted to say that they had to be on some sort of fixed path. Okay, they weren't just bouncing around and they're completely unorganized, right? So he recognized that it was something like a solar system. So in the middle you would have a sun, or in this case the nucleus, right? And the electrons would travel on these orbits like the Earth travels around the sun every 365 days on the same orbit, right? That's what he thought electrons did as well. He also proposed they existed at different energy states. So the electrons, when you put energy into them, would get excited and they would jump states. So you could have an electron here and it would jump up to this state, and then it would move up to this state and then move back down. But they were on these fixed paths. You could predict exactly what path they were on. Okay, turned out not to be exactly right. Oh, an important fact they like to ask about this model is that it only worked for hydrogen because hydrogen only has one electron, and so he really observed clearly that they were jumping to different energy levels. This is Schrodinger. This is the current model that we use in chemistry to understand the idea of an atom. It's developed mostly based on calculus or quantum math. Okay, a 90% probability of locating the electrons in the designated orbitals. So back to Bohr. A lot of these guys didn't know exactly where to find the electron. I think that was pretty well established across the board. And even Schrodinger's model isn't really perfect, but it has a much higher probability of locating electrons. So we know that they stick kind of around in these areas. And each of these little balloons, so in the center here in the purple, that would be the nucleus. These little balloons are kind of orbitals. So that's kind of where you would expect to see the electrons at certain energy levels. And we're going to talk a lot more about Schrodinger as we move forward with electron configurations. But his basic theory was based on quantum mechanics or math. Okay, so that's all the models that I'm going to talk about. Feel free to do your own research, answer the questions. We'll talk a little bit more about this before we take the quiz tomorrow to clear up any misunderstandings. And that's about it. Have a great night. Thanks for tuning in. Great.